Okay, so I'm going to record this video real quickly about how to work with linear graphical analysis. This is an app that you can get from the Chrome Web Store and add to your Chromebook, and it's great for making graphs for not just science class, but for any class in which you have to make graphs. Okay, basic layout. We've got a data table over here that we're going to put some data into, and then over here is our graph. Notice it's labeled XY. X is associated with the x-axis, Y with the y-axis. This would also be our independent variable in an experiment. This is our dependent variable. First, to enter in data on each of these columns, there's a little option button. If I click on that, I can go to column options, and I can enter in what I am measuring and then also the units that it was. And when I click apply, it renames the data column, but it also puts it on the graph, which is really nice. So I go over here and I do that with Y. And I'm going to call this one position and put an M for meters next to that one. I'm going to hit apply. And now I've got time and position. I got position and time over here on my graph. Things are good. Then I can enter in my data. And as I do this, I've entered in my data. It automatically plots my points for me. It's all done, which is really nice. Now, graph is supposed to have a title. To do that, I go down to graphing tools and I click on edit graph options. And here's a spot where I can put in my title. So I'll enter my title real quick, and then I just click back on the graph, and there's my title has been added to my graph. So I've got all of that. What if I need to put in a line of best fit? Well, I can go back to graph tools and click on apply curve fit. And there's some different options here for types of stuff that we can add, but we're always going to be doing linear. So we'll put linear and then we hit apply. And not only does it give me my line of best fit, but I also get this information box right here. And I get the generic line equation y equals mx plus b, where m is our slope. And there the slope has been calculated for us. B is the y-intercept. There's the y-intercept. It's all figured out for us. It does not give us the units with it, but I think we can do that on our own. So I have that graph. If I had a linear data set, then that is all I would need to do. What if I needed to turn this in into Edmodo, put it into a Google Doc? How would I go about doing that? Well, up here in the upper left-hand corner is this little piece of paper looking button. If I click on that, I've got some options here, save as, export. A really good idea is anytime you create a new graph is that you save it. Saving it will save this data file for this graph so that if you needed to open it up, change the data, change anything on the graph, you could do so without having to redo the entire graph. But if you wanted to turn in the graph to me or put it in a Google Doc or upload it to Edmodo, then you would need to go to export. If I click on export, I get two options. The option that you would be using to turn in your graph is graph image. And when you click on graph image, it'll open up a save feature. It'll save it as a image file that you can then upload into a Google Doc or turn into me through Edmodo. Now, what if we had a more advanced data set? What if we had something that was not linear? So I'll take that out. I'm going to change my data here real quickly. Okay, so I've changed my data. And here I have a graph that shows a line that's curving upwards. So for more advanced classes, if you have something that looks like this, and we can't put a line of best fit in this because the data set's not linear, how do I go about making it linear? Well, in advanced classes, we talk about how to do curve fitting. And so in order to do that, we would have to manipulate some of this data in order to make it linear. So let's show you how to do that. Well, in this case, because it's a top opening parabola, to linearize it, I'd want to square time. So if I go back to my time column, more options, I can click on add calculated column. And I know I'm going to want to square the time in order to linearize this. So I'm going to call it time squared with units of second squared. And then I'll click on insert expression. And to do that, then to get my squared, I'm going to pick this one right here, because it's going to take my variable, which is listed as x in here, and it's going to raise it to some power. So that's the one that I want. The parameter, if you wanted to have a multiplier out in front of this, I was going to do like 2 times the time squared or 3 times the time squared, I would do that, but I'm not going to do that. It's just going to be 1. I want to take my data column of time and I want to square it. So this is all set. I hit apply. And you'll notice in the data table up here, I now have time squared, and it squared all my values for the time. And it changed it down here on my graph. If it hadn't changed automatically on my graph, you notice I can click on this here. It's shown up as a button. If I click on that, it allows me to select whatever I want to put on any of these axes. I can do the same thing on the y-axis as well. And so I have my data set there, and now I can put my linear line in, and now I've got a linear data set. So now I can turn this in. Okay, that's it. That's the short and sweet of it. If you have any questions about how to do anything after watching the video, let me know. But I think graphical analysis, if you play around with it for 5 minutes, it's pretty straightforward.